It appears that we have just solved a portion of a recent geologic mystery regarding the origin of two mysterious tsunamis that struck Japan on October 5th and then again on October 9th, 2023. After much debate, the culprit appears to have been a deep yet explosive volcanic eruption at a previously unknown submarine volcano. We only learned of this fact 18 days after the first tsunami occurred when an overflight of the region where the recent energetic earthquake storm occurred revealed a massive slick of floating light brown rocks on the ocean's surface. This long and thin slick represented fragments of pumice less dense than seawater in what is known as a pumice raft, where high silica gas-rich rocks float to the surface during an explosive eruption of a typically dacite or rhyolite composition. For now, let us focus on the exact sequence of events which generated the larger of the two tsunamis, with the second event actually causing several small boats to capsize, meaning there was some damage. The second tsunami formed on October 9th, 2023 at 5:26 a.m. local time when a moderate magnitude 5.0 earthquake struck offshore of a completely uninhabited volcanic pinnacle in Japan's Izu Islands referred to as Sofugen, originating 1,000 meters or 3,281 feet below the ocean floor. This quake somehow generated a tsunami, which was subsequently detected by several ocean buoys before going on to strike Japan's Izu and Bonin Islands, but also the east coast of Mayotte, Japan, and Ryukyu Island. While the maximum run-up height of the wave was only 12 to 60 centimeters or 4.7 to 23.6 inches, the fact that it was so wide-ranging was quite unusual for such a small event. In a previous video, I had suggested that an underwater landslide perhaps with a volume of 50 million cubic meters was generated by the 5.0 earthquake. I supported this fact via what appeared to be a continuous tremor that preceded the main quake, claiming this tremor represented the slow creep of a large mass of rock before it catastrophically collapsed. While this still could be correct, since we now have to factor in a volcanic eruption in all of this tremor might have represented something completely different, as this tremor likely represented either the buildup of pressure before a powerful explosion occurred or the sinking of a hidden volcanic caldera on the ocean floor. In the region where the pumice raft was found to intersect closest to the magnitude 5.0 quake, the ocean depth was approximately 2,400 meters or 7,874 feet. At such depths, there is the pressure of 238 atmospheres, meaning that while a powerful volcanic explosion could occur, it would only last for a few seconds at the most via creating a giant gas bubble which would soon collapse in on itself. As water rushed back in to fill this void space, the displacement could generate an overlying tsunami. Tsunamis occurring due to a large volcanic explosion are not unheard of, as that was part of the reason why Hunga Tonga Hunga Ha'apai produced a tsunami on January 15, 2021, as part of a 60 megaton TNT equivalent explosion. By comparing the height of the tsunami to a United States nuclear test that occurred at 600 meters depth in 1955, I was able to calculate the approximate minimum size required for the measured two tsunamis to have been generated. My results suggested that the October 5th tsunami could have been generated by a 490-ton TNT equivalent explosion, with the October 8th being caused by a 3,983-ton TNT equivalent explosion. The latter of these would have generated a temporary air bubble comparable in volume to a modern-day United States aircraft carrier. The second highly plausible theory is that a phased volcanic caldera collapse occurred on the ocean floor, either due to a large volume flank eruption like witnessed offshore of Mayotte in 2018, or, more likely, a large explosive eruption whose volatiles were unable to climb more than 100 meters above the ocean floor due to the atmospheric pressure there, unless they were less dense than salt water. Thus, as a section of the caldera collapsed downwards to fill an empty pocket of the underlying magma chamber, water would rush downwards and then rebound, generating a tsunami. The answers to the many questions posed by the latest data will likely take substantial time to answer, as an underwater mission is needed, in my opinion, to find the source of the volcanic eruption which occurred. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.